of motion. So what is Newton's second law? Why it is stated? What is so important about the Newton's second law? So Newton's law is all about a body having some mass and some velocity. So considering these two factors, there will be a force existed on a body. So when there is a body in a movement, there will be some force. That force is defined in a Newton's second law of motion. So let's see what does it states. The acceleration of an object A, acceleration A, we can acceleration is defined denoted by A symbol of an object as produced by the net force. Net force is directly proportional to the magnitude of the net force and inversely proportional to mass of the object. Acceleration, okay, A, directly proportional to the net force and inversely proportional to mass of the object. So this can be written as F net directly proportional to M into A. Okay, and the proportionality symbol is removed and K is the proportionality constant, K into MA. When consider a case where K is equal to 1, so F net is equal to M into A. This is how F is equal to MA formula is derived. Okay, one more statement is there. Force is directly proportional to the rate of change of momentum. So what is momentum? Momentum is a product of mass and velocity. Okay, M into V. We shall derive from the second statement, F is equal to ma. Suppose a body having a mass m with the initial velocity u, when a force is applied F, the body changes its velocity from u to v. So initially body having a momentum of mu. P is the momentum. Finally, when after applying the force, the body has got a momentum of P is equal to mv. Okay, so as per the second law, second statement, force is directly proportional to the rate of change of momentum. Rate of change means per second. So with respect to time, when it is defined, it is called rate of change. Okay, so F is directly proportional to mu minus mv by t, and m is taken as common, v minus u by t. So with the kinematic equation, v is equal to u plus at. So if we make this equation for t, v minus, for a, if we make the equation for a, v minus u by t, substituting this a into this equation, this becomes m into a, force. F is equal to ma. This is how the formula is derived for the Newton's second law from the second statement, that is rate of change of momentum. Okay, so consider one more thing. When the forces are balanced, so when a body is an object is there, when the forces are balanced from the surroundings, from the all around the body, so that is where acceleration is equal to 0. In that case, acceleration is equal to 0. You can consider two things here. when the body is at rest, the acceleration will be 0. When the object is in motion with the uniform velocity, when the body is having uniform velocity, acceleration is again 0. So okay, in that case F is equal to ma and acceleration is equal to 0, force is equal to 0. In the both the cases, when the body is at rest, the force will be 0. The object is in motion, considering an uniform velocity, in that case acceleration is 0. So in the formula becomes F is equal to ma, a is equal to 0, F is equal to 0. So the body means forces, net force acting on the body is 0. So consider case 2. Forces are unbalanced, means an object is there, the forces are not balanced. Here two forces, 10 10 each, and here also 10. So net force acting on the body is 10 Newton towards the right side. Okay, towards the right side. So what happens? There will be an acceleration in the body due to the net force acting on the body. Considering the mass, suppose this is having some 10 kg of mass. So from the formula F is equal to ma, force is 10 Newton, mass is 10 kg, A is equal to 1 meter per second square. This is how it is derived. Acceleration directly depends upon the net force. Acceleration depends directly upon net force. The acceleration is inversely upon the mass of the object. This A, if we derive the equation for A, this one becomes A is equal to F by m. This is what the second condition said. Acceleration depends inversely upon the mass of the object. This is the mass of the object. Okay, I think I have understood.